The focus of this lesson is on graphing exponential functions using transformations. So it's very important to determine who your base is in your function, and then also you want to rewrite your function in such a way that you can see all of the transformations. So in my case, we can see that the base is e because that's what's being raised to the power. So I'm going to rewrite that base with a different color just so I can see all my transformations in light of that. So e is multiplied by 3 and it's raised to the 4 minus 2x power. So I want to change the order of that so it says negative 2x plus 4 power. And then I'm going to rewrite it one more time. And I'm going to factor out the leading coefficient on x because that helps me determine the different transformations that I have. So it's negative 2 times x minus 2. So that's my power overall. And so that allows me to see the transformations on my parent function. So who's my parent function? Well, my parent function is just my base raised to the x power. So in this case, my base is e raised to the x. So that's who I'm transforming every day. Think of this as I'm starting with that parent function e to the x, and then I'm going from there taking care of every transformation that f of x has, and I'm going to use that to be able to graph point by point. And so to start off, if we were going to graph our parent function, so x and our p of x, which again our p of x is e to the x, we'd see that when we pick our x values, negative 1, 0, and 1, e raised to the negative 1 is just going to end up being the reciprocal of e, which we know to be approximately 0.37. And if you have a calculator, you can always confirm that. E to the 0 is just going to come out to be 1. And e to the first, well, I know that to be Euler's number, which is 2.72 approximately. And so those are my three key points at the end of the day. Negative 1, 0.37, 0, 1, and 1, 2.72. So then in light of that, I need to take care of each of my transformations that are in this function. Well, f of x has a multiplier of 3 on our base, and so that means we have a vertical stretch by a factor of 3. So if we have a vertical stretch by a factor of 3, what that means is all our y values will triple. So you'll keep your x values, but each of the y's will be 3 times as much. So if we do that, if we triple 0.37, we'll get 1.11, 1 and 11 hundredths. If we triple 1, we get 3. And if we triple 2.72, we get 8 and 16 hundredths. And so this is all from my vertical stretch by 3. Then moving on from there, we have this negative on our x's, this negative multiplier. So that causes a reflection across the y-axis. So what that means is I just need to negate each of my x values. That's the behavior. So whatever my x's were, I'm just going to change the signs. And I do nothing to the y's of my points. And then I have this multiplier of 2 on my axis, but that's just a horizontal compression by its reciprocal, so a horizontal compression by a half. So whatever I had for my x's, I now am going to cut them in half. So it's half, 1 and 11 hundredths. Half of 0 is still 0. Keep your 3. Half of negative 1 is going to be negative 1 half, 8 and 16 hundredths. And then last I have minus 2 for my x. Well, that means just go right 2 units. So whatever my points were, I need to shift them right 2 units. So I need to add 2 to my x values. So 2.5 or 2.5 and 1 and 11 hundredths. is my y. Add 2 to my x in the next point, it would be 2 comma 3. And then add 2 to negative 1/2 and I'll get 1.5. And then 8 and 16/100ths. And so that takes care of all of the different transformations I have. So those are my final points, which I can put in my table here as far as 3 key points. So I'm just going to rewrite them, and then we would just graph them. And 2.5, 1 and 11/100ths is approximately there. 2, 3, and then 1.5, and then 8 16/100ths. It's approximately there. And keep in mind the transformations you had as far as their effect on your horizontal asymptote. A vertical stretch by 3 would not change your horizontal asymptote. A reflection across the y-axis would not change your horizontal asymptote. Horizontal compression wouldn't change it, and going right to would not change it. The only thing that I would keep in mind is exponential generally has the shape that I'm kind of fake drawing, but then when you reflect across the y-axis, it's going to change the direction of your shape. So you're going to go from this direction, and then you'll approach that x-axis at the end of the day. And so you have this horizontal asymptote still at y = 0 because none of the transformations affected that. And so if you were asked for the domain, your domain is all reals, and then your range goes from 0 non-inclusive to positive infinity. And then you have your 3 key points of your final function, you have your horizontal asymptote graphed in, and you have the general graph. And so this completes the graphing an exponential function with transformations.